is Pavel. I'm the co-founder and CEO of TechTree, and we're bringing this amazing event together with Francesco, who's the founder of Silicon Roundabout, one of the biggest and oldest tech communities in London. And I think the idea behind the Show the Codes events is simple. So we're all talking about the tech sector, we're all talking about tech companies, etc. But we almost never give the spotlight to people who build this tech. And the role of Show the Code is to give the center stage to developers who are building these cool products that all of us use, and to share what they're working on, and to answer questions about that. And this is, I think, the 8th edition of that. This time we've partnered with MMC Ventures, which is one of the top venture capital firms investing in very cool tech companies, some of them already unicorns, some of them soon to be unicorns. And we're gonna have 3 amazing companies and 4 amazing engineers sharing a little bit more about the inner details of these companies. And that's it in a nutshell. And I'll hand over to Francesco so he can speak a little bit about Silicon Roundabout and what they're doing and how you can get involved.
I'm Francesco and I run Silicon Roundabout. If you're part of our community, great. You probably have seen me before jumping around on stage or on one of these webinars. If you don't know me, just very quickly, I'm actually a software engineer, been building code for the last decade at this point, nearly getting to 10 years now. And in the meantime, also grown this amazing community I'm privileged to be the co-founder of. And with this community, what we do is we support startups, engineers, and investors coming together to build an ecosystem. We're now the largest ecosystem of this sort that started out of a meetup, and we're very proud of our meetup. So Pavel said, how can you get involved? Just join the meetup and check us out on siliconroundabout.tech or on meetup.com/Silicon Roundabout. Everyone is welcome, and together we love to build new tech. And since obviously startup has always been associated with most like the business pitch has been great fun so far in the last 8th edition to work with Pavel on actually give the spotlight to us, the CTOs, tech leads, coders, hackers, and whatnot, and actually talk real code. And so far it's been an amazing journey. Actually, all these events have pushed me on the side to make some GitHub repos recently, just based on like technologies I've seen used by other companies. It's been a great fun so far. So what we want to do is to continue on this journey, inspire more engineers to build. And if any of you, despite alongside building tech as an engineer, also comes up with a startup idea and starts to build your own company, then also let us know, because we now have a venture fund. We invest in high technology startups at pre-seed seed. So anyone who's got an awesome idea that has turned into an MVP, and now that MVP starts to have a little bit of traction, doesn't have to be much. It could literally be early POCs. Get in touch. Always happy to get to know more people and support the entrepreneurs and the engineers in our ecosystem. And I think that's all from my side.
Yeah, amazing, Francesco. Thanks a lot for the overview. And yeah, everyone, if you have amazing companies that you're working on, feel free to reach out to Francesco. And now, Francesco, thanks a lot. And I'm gonna welcome Luca, who's gonna be our first speaker.
Cool. I'll jump off stage. Thank you very much, guys. And I'll be sitting here, maybe even asking some questions.
Yeah. Thanks a lot. Great to see you, Luca. You can check whether your screen sharing works. And while you do that, just a bit of intro. So, Luca is a CTO at Signal.ai, very cool data analytics business. It's also an interesting business in the history of TechTree, because almost 2 years ago, before founding TechTree, one of the first people I spoken about the idea was one of the co-founders of Signal.ai. So it's really interesting to see them on our event 2 years later. And Luca, you have exciting growth story behind you and in front of you. So over to you.
Yeah, thank you, Pavel. Thank you very much. And really excited to be here and share more about Signal AI and the technology behind that. And, the meetup is called Show Me the Code. I'm not going to show much code, but I'll show, I promise you, very interesting architectural solution and mostly the mindset behind those architectural decisions to have an idea how we are supporting the growth of Signal AI over the last few years, and how we're actually driving that growth with technology rather just following those decisions. So already 2,500 years ago, Heraclitus, there was a Greek philosopher said, the only thing constant is change. The word on that specific has not changed much, because this is even more true than in the past. The world was at much lower place 2,500 years ago. But fast forward now, 21st century, society is changing very quickly. And the businesses embedded in societies are evolving and growing very, very quickly. And, technology companies like Signal AI and like all the companies you guys are working in need to evolve and adapt to the world and to the needs of the business growing. So the question that we all have as engineers, as a technologist, is how should we deal with change? Because sometimes change is a difficult thing to deal with. And as a technologist, we have a great technology vision. We have our code, we have our systems, our services, and not all the time we are necessarily ready for that change. So how can we start thinking a change, actually a lever of acceleration and growth, even from a technology perspective, rather than actually feel it as a constraint for ourselves. The first thing that I want to highlight is why change is so important in Signal AI. And I'm sure this is our scenarios where they're not just related to Signal AI, but by giving you in a moment of a couple of the flavors about what we're doing, you probably understand also the size of the changes and the pace and the speed of things are changing, evolving in the business and therefore in the product technology, because at the very end, we are a deep tech company, so product and technology is the driving force of the growth. Signal AI is this transforming decision making. We are building a platform that is helping people taking better decisions. The volume and amount of data out in the world is way too big for any single individual, between newspaper, online, digital outlet, social, podcast, broadcast, you name it. There's way too much stuff for anyone to be on the top. What Signal is doing is ingesting a lot of these documents in pretty much real time. And then we use machine learning, in particular, we use natural language processing to start making sense of the amount of data. So we spot things that matter. We identify in any given document that we see, we identify people, organizations, locations, products, ingredients, and also identify topics. So things like innovation, things like sport events. So we're able to start creating a bit of a context around that. It's not just a piece of text. It's actually a text with some meaning. And whilst also following that, we interpret that data. When we identify that a document is about a specific person, a specific organization, we also understand what is the sentiment around that specific person or organization. Is it a positive sentiment or is it a negative sentiment? We started understanding how a company and a specific topic is they're correlated. Do we see a lot for a company be in the news with the innovation tag? So actually, probably the company has a very strong innovation brand, or actually we don't, or is anything that is concerning. And on top of this amazing platform, we build a number of products that serve different industries to take better decisions. The fact that decision making is an activity that we all take as humans. So by nature of the product, we can play in different industries by using this NLP and the support of user that can also train some of these NLP themselves. Now, this is a power platform, but there's a lot of technology behind that. And just to give you a measure, we ingest about 4 million documents a day, so it's a fairly high volume documents from a variety of sources. So we just don't ingest traditional media like newspaper, but we also ingest broadcast, we ingest social data, and overall we see up to 4 million others, and it's keep growing. But it's also a fairly high throughput system. The mean time of ingestion is about 30 seconds. So this is an interesting one, because if you take the 30 seconds in isolation, it feels slow, but actually it's quite the other way around. If you think about it, that means that every given second we have, as average, about 50 documents that are fully classified. And on any given document we receive, we run hundreds of different machine learning models against it to really make sense of it and extract value. Also, documents don't have an even distribution. So it's not that every given second we receive the same amount of documents, because we follow the cycle of events in the world, especially with the news. If something big is happening in the world now, in the next half an hour, there's going to be a crazy amount of data coming through the digital outlet. So that distribution over time, those spikes, is something that from a technology perspective, we have to be able to absorb. So the 30 seconds is actually the average. That means that most of the time we ingest these massive amounts of data, fully classified with 100 of machine learning models, like in probably 5 to 10 seconds. The 30 seconds actually when our technology has to kick in and auto scale to support the spike to respect that internet SLO. So there are a lot of moving parts. It's not just the business that is moving fast and experimenting new things, but the technology itself has to grow. I talk about this, right? So as a business, we work on many dimensions, right? We talk about the real time. We like our SLO near real time aspect. We want to maintain it. The scale in the content set is keep growing. It's 4 million documents now. In a year time, might be double. How do we deal with an extra 4 million documents? What do we have to do as a technology to support that? We are a deep tech. We work a lot with machine learning. We have a research team working very close to our engineering and product team. How do we keep innovating and scaling in the NLP space? How do we allow the research group to experiment with real data, with new models to validate that we achieve the right quality? And the ability to play multiple markets is an important thing for us, right? We said it is a decision making is a horizontal capability. Although we started with a specific industry from a business perspective, we need as a business to play on multiple markets. So how do we support a business in rolling out products in different markets? So keeping all this in mind, how we deal with all these changes, a lot of changes. There is business needs, there are technology needs. How do we deal with that without becoming the blocker to the business? And actually, the only way is about embed change in your software as a core principle. And this is something we started from the beginning, but over the last years, it became much more a first-class citizen in the way we think about designing the software, we think about architecture, and as a consequence also how we design every single service in our microservice architecture to support this principle. So naturally, when we think about an evolving system, our mind, went close to evolutionary architecture. So evolutionary architecture, for who is not following that, is a set of principles about how to think of your technology system, all your microservice architecture. It doesn't have to be a microservice. It could be any type of any system, in a way that will allow change, support change. So pretty much we create a system is built for change, is built for change. And there are 3 main pillars to support that. The first, it has to be incremental. So, system built with an evolutionary architecture mindset are built one part at a time with many different increments. And the speed between one increment and another is the key. So not all the time is easy to improve that, but it's an important thing to keep in mind. If you're building for change, what you're doing is setting yourself up for easy change. Easy doesn't mean automatically short or anything like. It means faster than otherwise. It might still take you 5 months or 6 months or a year, but the fact is those 5 months are probably half of what would be otherwise required without that mindset. The second pillar of evolution architecture is really around defining a fitness function. And this is, in my opinion, is one of the most critical elements to embrace when you want to have an evolutionary mindset in the way you think about your product. So every single system at a different point of life need to optimize to be fit on a certain environment. And systems and code are evolving over time. And we talk about technical debt. I think is an unfair definition actually for what we do. I like to talk more about different generation of systems, because technical debt has an implication that we did something bad in the past. That's not the case. We're just evolving the system to the next generation of requirement or expectation. And fitness functions are very effective in this way, because what you describe is your final fit state where you like your architecture to go. And in one way, it works a bit of as North Star to move in that direction and achieve the final current state of fitness for your system or your service. And at the same time, it gives you also confidence to understand how far you are, because being an incremental system, you do not expect to achieve your final stage overnight. It's okay to achieve it over time, as much as you keep measuring what are the fitness function elements that you have in mind, and keep evolving in that direction. The interesting element, because we're talking about generational changes, right, is no more about technical debt, it's about different generational code and software. Your fitness function can and should change over time. The moment you achieve the fit level that you describe now, you pretty much achieve the right generation of your software system or your code for today. But if it's 6 months, you have to move the system to the next stage, the next generation, your fitness function will change, and the fitness function can be everything that makes sense to you. I'm going to give you a couple of examples in a second, but I think anything that will make sense, from scale, to security, to open up new business opportunities, to performances. It's up to you. Whatever is the next stage of development and growth and how you want to evolve your system, the fitness function is there. And the third pillar for evolution architecture is really about being able to think in multiple dimensions. Evolution architecture is all about technical and domain changes. It's not just about technology. It's not just about the business domain. It's supporting both. The best approaches to the evolution architecture is be able to support and drive the changes that the business is want to achieve, is pursuing, with a technical mindset and the ability to describe what's required to support everything. Often, cross-functional requirements are a great example. Security is a good example. Performance, another good example. But what if we want to open a new market? How do we make that happen through our technology design? So keeping that in mind, there are 3 areas that are good examples of how we use that mindset in Signal, and how they help us think differently, but also how we use our ways of working, our principles and practices to support evolution architecture. Because you can have a great session about architecture design or service design and start writing the code, but what are the principles and the practices that you put underneath to supporting, actually not just supporting your incremental mindset, but actually accelerating and boosting it up. The first example of evolution architecture approach in Signal AI is a pipeline that became a platform as a service, so a PaaS. If you remember the initial picture I shared with you of Signal, there was a big box where actually we start doing all the classification. So given a document as ingested, we are applying all these models, 100 of machine learning models, to extract meaningful metadata that are enriching the single document, so that we go from a document with really no context, we don't know what it's about, to a document with a lot of context, with a lot of information and a lot of relevant metadata to help people make the better decision. And correctly started as a normal pipeline, because at the very beginning, in early stage of Signal AI, we were only working with a single data set. We were working with media, traditional media. And that was a traditional pipeline where a document was coming in, and there was a number of services where the document had to go through. And it was like a document that was doing entity extraction, and now there was doing entity linking, and now there was doing topic extraction, and then it was about sentiment analysis. And at the end of this conveyor belt, we were saving on our database. In particular, we've been always working with Elasticsearch, and we keep working with Elasticsearch. It's a great piece of technology. But there was this conveyor belt of event that would allow us to go from a document, a lot of text, to a lot of text information. We understood actually, because what we're building is a bigger and a more ambitious platform about helping people take decisions, we had to introduce a different level of abstraction. So we moved from having discrete services, the entity extraction to entity linking, to a number of capabilities to create a platform. So right now also we have a platform and we talk about what are the inputs API. So if before the way to pass a document to the system could be only one and only one, now we can think about have multiple ways to introduce the content to the platform. Why this is important? Well, first, because they will allow us to deal with different type of content set with a different velocity in the industry in different ways. Second, because by having different ways to introduce documents in the system, we also give ourselves the flexibility to open up new business opportunities, how to make the platform even a more central concept in our system. And we talk about routing, we talk about serving, we talk about scaling. So we change the level of abstraction, and by changing the level of abstraction, we also help ourselves to have different implementation. And if you think about the three pillars about evolutionary architecture that was shared before, we've been able to answer some of those very effectively. You know, we are able to maintain our near real time because now we have a much more sophisticated platform that is evolving, so that we can actually have more flexible scaling and more effective scaling because we have a different granularity of the services. We're able to ingest diverse content set very effectively. Now we can always plug in new content set, and we can have a very effective way for route it through the system to the right machine learning models until they're ready for being stored or distributed in another way. And this is also helping a lot about NLP experimentations. Our engineers and our researchers can really push the boundaries of what NLP can do in helping people taking better decisions by creating new models, deploying it in a system. The platform now is able to manage the routing of different documents to specific systems in a very effective way, in a more programmatic way than not. And so people can very quickly see how this is working effectively. From a fitness function perspective, I said this is probably, in my opinion, one of the most important effective things about evolutionary architecture, how to think about. Well, we start being able to measure much more effectively ingestion performance. If before was a bit of a conveyor belt, so there was a compound value of ingestion, from S1 to S4 to storage. Well, now we have better boundaries around ingestion and performance. Of course, cloud cost management, it became also easier. We have better understanding of the different discrete phases of the system, and it's also helping us by measuring it. First, we can set ourselves some target, but also we can be much more proactive, understanding if actually serving is becoming a problem more than anything else. What are the options about making it better? Finally, evolutionary architecture is all about supporting, business and domain, and lead time for us, and definitely for me as a technology, is super important. We are in business and moving fast. We want to innovate at pace. We really want to move at pace and experiment in the market with new ideas. So the lead time is from a team, a person has an idea, to when this idea is into the market and is monetizable, right? As a technologist, how do we make the lead time as short as possible? How do we empower people to be as fast as possible and innovate? And transforming the pipeline to a platform is actually empowering all the teams that are, aligned to specific markets, so our market, aligned kind of teams, to really work effectively, create new models, deploy in the platform, and keep working, moving towards their goal and serving their customer. In the same way as a technology, we use our cloud provider with certain building blocks, translating with evolution architecture principle, the pipeline to pass, help us a lot in that direction. The second example that I want to talk about is our front end. We apply the same principle that we use in the big platform that is about ingestion to the front end. And as before, we started with a very clear goal in mind that was serving the PR and comms industry to help them take better decisions. But along the way, in the same way for the big platform where all the models run, we understood that our system, our product is much more flexible. It can be served much more many markets. So how do we support the business from multi-market innovation? Well, we start working on a micro front-end architecture where actually we have number of a micro front end that can be managed, by different teams. So, you have in various Conway load that you can apply, and potentially also working on components that will support that. In the same way as before, we've been able to support the business. Actually, we're accelerating the business into moving into multiple markets. Right now, we have a better articulation on why it will be, how long it's going to take to go in a new market if you want to build a new micro front end, a new model. At the same time, as before, product experimentation is absolutely there, because we allow different teams to start and play with new market and test new ideas. The fitness function are very similar. Lead and cycle time, again, it's changed, so we want to embrace change, and part of embracing is accelerating our lead and cycle time. But also at the same time, we start measuring the performances, low performances. The moment you have micro front end, your bundle size will go smaller, so we'll get even better performance. And to a degree, error budget. We're going to be in a place where actually in our single page app, we have a better understanding where something does work, because it's better modularized. And therefore, we can have a more controlled approach and have also overall a better experience. And I talk about these two examples, but as I said before, you need also principles and practices to support your evolutionary mindset beyond the architecture. And so what we need the Signal AI, we adjust end-to-end to that mindset. Continuous delivery, it's a critical one for us, and we really push it to the edge, as we really believe in trunk-based development. So we really encourage everyone to work on short-term living branches and continuously merge back to trunk or to master, so that we're all aligned on the code base. No one is behind, so integration is not becoming a problem. The second thing, in the same way for continuous delivery, we really focus on working as close to production as possible. We work heavily with feature flags. So when you build a new system, you actually going to deploy in the actual production system behind the feature flags. We don't work a lot with staging environment. Even if it's internal use, we encourage people to put it in production behind a feature flag. So the system is going to start being stressed by the volume and the size of the usage, and we'll get immediate fast feedback, so that our architecture will change and adapt also based on those feedback. We fully embrace DevOps philosophy. So you build it, you run it. Each team is responsible for the build and the systems that they create. And this is very important, because in the same way you want to build and evolve your architecture, you need to understand what are the elements that you want to change. And by have the ability and the requirement to take care of your system when it's live and in production, you have a number of very useful feedback to understand how to change it down the line. And of course, the right tool for the job. This is a list of some of the tools that we're using, but really it's about helping people to say, if you want to be incremental, you want to be a change mindset, go and find the right tool for the right job. I think that the best example that is around data stores. We have a number of data stores that will help us understand what is the right data modeling that will allow us to change and evolve the system at any given point in time. And the interesting part here is that if you look at data modeling, the right data store might not be the one that you think immediately about, because there is in an incremental and evolution architectural mindset, you really want to think about what is the right data store for a given point in time. One example is that we've been working for the last period over a knowledge graph, and more and more connect the different concept and principle in our system for discovering unknown unknowns. And naturally, there's a place in time where actually, a GraphDB is the solution. So it could be Neo4j. But at the very beginning of this exercise and experimentation, it was not based on Neo4j or any other graph database. We actually work with a mix of Athena and PostgreSQL, because there was enough for the volume of data experimentation we're doing. While we knew that it was enough to serve, we knew that the long term was about Neo4j or any other solution. So again, we use the evolution architecture mindset to embrace change and really see the different stage of architecture and software design and software and coding based on what we need. So the reality is, like, we need to want to embrace change. And the way you want to do as a technology system is really a technology company is to be proactive. If you're proactive as a technology team, you're going to lead the change. And exactly this is one of the secret sauce of a fast-growing business, right? Evolution architecture is our way, a signal way, but it can be used by, in any other context to drive the changes, right? We adjust our ways of working, the way we work, the trunk-based development and all the other techniques to support and enhance their mindset. All what we want to have is having a malleable system that will make changes easier, whatever time will take, than not have a clear direction of changes and flexibility evolving over time. So the other thing is like, yes, we started saying the only constant thing constantly change, and this is just a fact. And the way to deal with it is, embracing it and using to actually drive the business, open up opportunities, and help everyone in technology, outside technology, to really think in a way to really innovate and push the boundary. And hey, if you guys are interested in these problems, we're growing. Come and have a chat. We're hiring and we're keen to meet a lot of you. Thank you.
Thanks a lot, Luca. That has been like super interesting insight into your growth. In terms of, we went slightly over time, so there's not going to be much time for questions. But just maybe one question is like, what do you think is the next key challenges for like the fun things that you're going to be working on in the next year or two?
Great question. Well, some of the things I just presented are still a work in progress, so there's a lot to finish. By the nature of being an evolutionary architecture, this is like just the next generation. There's a new piece of work that's gonna emerge more and more that is an even better way to search and aggregate data and content at scale. We have these millions and millions of documents, billions of data points. How do we allow all the products on top with the micro front ends to be able to search and aggregate at scale so we can build even better experience? This, I think, is going to be one of the exciting challenges for the years ahead, and more pushing on new market with different product experiences on the top. These, I think, are the two.
Great. Well, thanks a lot, Luca, and the presentation will be available after the event as well. So feel free to reach out to Luca either here on LinkedIn, and my colleague Samuel has also posted some more information about Signal AI and their company and the roles they're looking to hire for. So yeah, thanks a lot, Luca.
Thank you, Pablo.
Okay, and you can now press the leave button in the upper right corner, so we can invite Chris and Steve. Hey, Chris.
Hi.
Hi, Steve. Good to see you guys. So you can launch your presentation.
Sure, just give me a second, pulling up the right tab.
Yeah, so Chris and Steve are part of Bloom and Wild, which is a company that is probably the biggest company in Europe helping people to receive amazing flowers. And it's required quite a lot of tech investment and growth to be able to do it at the scale you guys are doing it. So it'd be interesting to listen to that. And it looks like everything is okay. So over to you.
Thank you, Paul. Hi, everyone. My name is Steve. I'm an engineering manager here at Bloom and Wild. And this is my colleague, Chris, who's the lead backend Ruby developer. So we're going to talk you through a little bit today about what we do and some cool apps that we've built in recent times to kind of help people out in the warehouse and where our warehouses are going. And that's a bit of a view into 2021-22. So thanks, Paul, for the introduction. A little bit more on Bloom and Wild. So most people know it as a flower brand, which is what it is, but it does run on technology. So we are the leading European online flower delivery company, and we operate in 8 markets. You may or may not have seen in the news that we recently acquired a European company called Bloomon, and that actually added quite significantly to the number of people in our organization. So we've now recently crossed 300. To put that into context, this time last year, we were just hovering around 100. We have 50 engineers located in multiple countries. We've organized our development teams into squads that fit neatly into the customer purchasing domain. So, for example, you might have checking out, as in like putting flowers into your cart and clicking on that and all the responsibilities that go with that. That's a domain. Another domain becomes customer relationships. So like marketing emails, things like that. Another domain, which is where Chris and I live, is in fulfillment and delivery, which is after someone hits the pay button, everything that needs to happen in the background for some flowers to arrive at their house. We build everything from apps to fulfillment technology to front end. And in recent times, we're focusing more on enabling fast and safe changes at scale. So I'll hand over to you, Chris.
Cool, thank you. So yeah, next slide, please. I just wanted to talk a little bit about what our tech stack looks like, just sort of a high-level overview. So obviously the back end is the domain that I mostly live. I'm, a full-stack developer, but yeah, mostly back-end focused. So we have a website which is built in Angular. We have consumer apps, which obviously are Android and iOS. And then we've got a couple of internal apps that we use. So one's a delivery app, which is used by our delivery drivers, some of the ones that we hire directly. And, that's to basically upload a picture of where a package has been left and, mark deliveries as shipped in the system. And we also have a labeling app, which is used in the warehouse. And this is a piece of tech we added about a year or so ago, which I'll talk in more detail later on this presentation. And then to come over to the back end, so we have a Rails 6 app, and yeah, that hosts several APIs. So we've got the consumer-facing APIs that serve the website and apps, and we have some internal APIs, which obviously use for the other two clients there that are shown. So in terms of data storage, we use S3 a lot for a lot of our content that we serve and that we generate. And then we use a Postgres RDS database, although we've recently switched to Postgres Aurora because it gives additional performance benefits for us. We have our first microservice, which we built also about a year ago. And this sits in our team, mine and Steve's team, for the fulfillment and delivery squad. What it is for is to generate labels for the gift cards and shipping labels that we ship out from the warehouse. So each customer will get a gift card, which will go in the box. They can put a message in there and stuff like that. So the reason we split that out was because generating PDFs has different performance characteristics to the rest of our system. Requires more memory, more CPU. So it made sense to move that out of our psychic workers, which it was originally in, and move that into a service. And also, like, it's not something that we do all the time, like continuously. We kind of batch our PDF generation. So we are currently using Filegate, ECS, and Lambdas, and obviously only paying for the work that we actually do in the service, so we don't have to run a box all the time, or several boxes. And then obviously, we communicate with lots of external services such as carriers or other software services, sending emails and marketing, etc. Cool. So we'll talk a bit about warehouse tech. So the first thing I wanted to talk about today was zebra printing. So if we go to the next slide. Thank you, Steve. So yeah, as you can see, I'm not the best slide designer in the world. Basically got some images that I've shoved in here for you. So the image on the top left there is our one of our production printers in our UK warehouse, and there's a picture of, for example, of one of our gift cards that we've got there. So we embarked on a project to put Zebra printers in the warehouse. So these are used for printing our shipping labels. So before we had these, we had some very thin card with a shipping label attached to the inside cover of the gift card. This label would be peeled off when packing flowers, and the upshot of this is like it causes the printer a lot of problems, because the card is actually thicker on one side than it is on the other. So the sheets of paper and the feeder kind of stack at an angle, and that causes like feeding issues. And yeah, the quality of the cards were not great, so they're quite flimsy, and it sort of leaves this kind of film on one part of the card where the shipping label was before it's pulled off, after it's pulled off in. So we transitioned to use Zebra printing. This is a sort of picture of one of our initial sort of prototype setups. This was all connected via Bluetooth. There's an Android app there that communicates with the back end and fetches a label and also talks to the printer. So we actually moved away from using Bluetooth connectivity because there's some additional latency there, and yeah, sometimes you get connectivity issues. So we moved to a USB-C sort of setup, so everything's directly connected. So how it works is there's a QR code on the back of the gift card, which you can see in one of those pictures. And when basically what happens is the QR code is scanned and the label's fetched from the back end and printed on the Zebra printer, ready to be stuck on the box. So obviously, as a result of this, we have fewer paper jams, better quality cards, and yeah, like I think it just improves the customer experience, getting a better quality product at the end of the day. Cool. Got a short video of this in action. This is again one of our prototype setups. So the QR code is scanned and the label comes out. Pretty straightforward. Cool. So moving on, so to a project that we built recently. Again, this is app-based. So if we go to the next slide, this is an app we built to help with stock counting in the warehouse. So we've recently started to have to operate our own warehouses. So the first of which is in Germany, a place called Bergkamen, and that's now fulfilling all of our customers in Germany and Austria. So we had a bit of a problem here, which was like initially when we set the warehouse up, we were running everything on spreadsheets, and it was very difficult to have a view of what stock we've got and yeah, like where it is. So we built this app to help with stock counting. So you can create a new count there on the left-hand side. That second image is a barcode scanner. It's probably not a great image there. Basically, the idea is you scan a barcode which is on the product in the warehouse, and then you can enter the pack size and quantity, and then it's stored in the app and can be uploaded later on. On that last picture there, there's some stock count items in there, and what you can also do is you can click on one of those and like edit it, delete it, that sort of thing, if you've made a mistake. Cool, so this is what the upload looks like. So once you finish counting, you can upload your stock count. So we kept this simple. We could have integrated with like Google Sheets or some other backend. But we decided just to use app intents and then share it to Google Drive as CSV data. And this is like some test output that I'll put here showing that it works. Cool. So there are a few considerations when we built this. So there was a lot of third-party apps available, which we evaluated, like quite a lot of them. Some of which are free, some of which were paid. What we found was a lot of them were too complex for our needs. So there was a lot of initial setup, or you had to upload your product catalog in order to use the app. And yeah, it was felt that was a bit too much for what we needed to do. And other third-party apps were pretty straightforward and simple to use, but not very efficient. So it required too many taps, or you couldn't do continuous scanning within the app. So we wanted to make this process as efficient as possible to save our warehouse colleagues time, essentially. So we decided to go for an in-house app. And the good thing about that was we already had a load of code with regards to scanning and layouts and styles and sign on and stuff like that for the labeling app that we've already presented. So we were able to reuse large parts of that, which made it very quick and easy to build. And we also already have a private Google Play Store where we can publish our internal apps and push updates and stuff like that. Another consideration was in the warehouse, and this probably applies to all warehouses, we had patchy Wi-Fi. So that meant we had to store the data locally within the app. So we used an Android Room database, which is a wraparound SQLite to store the relational data in the app. And then at the point where you wish to upload it, the data's formatted and output into CSV format using Android intents. And because this is show the code, there's some code. Enjoy.
Thanks, Chris. So I'm going to take over for one or two slides. Something to bear in mind with when you work in e-commerce is that, like, I think people sometimes have a perception that when you work in tech, you want to work in like cryptocurrency or Bitcoin or like whatever is seen as like the bleeding edge kind of stuff. Something to bear in mind with e-commerce is that the tech that you work on will actually have real effects on real people, and that can be quite rewarding at times. So this is Thomas, our warehouse manager for one of our warehouses in Germany. To put into context, like the benefits of the app that Chris threw together. So before the app, Thomas and one of his colleagues were spending 3 hours a day in a refrigerated flour storage unit doing stock count. And let me get the laser pointer. Yeah, doing stock count. They were also spending 3 hours a day times 2 people counting goods coming off of a lorry every day. And then and that was all being done with pen and paper. And at the end of the day, Thomas would spend an hour and a half putting this into Excel manually. And this was on his train ride on the way home. Chris took maybe 3 to 4 days to throw together this app. And that was in around November of last year. Since then, the time spent in the refrigerator house has halved. The time spent counting received goods is halved. The Excel upload takes 5 minutes, so Thomas actually just chills out on his train ride on the way home. So this is one example of how tech in an e-commerce business can make real changes for real people. Like our stock counting app has saved dozens of hours, probably in the hundreds by now, in the warehouse. Another example of like tech being used is we integrated with a DHL API endpoint for them to be able to deliver Christmas trees. And you might think to yourself, well, integrating with an API endpoint isn't the coolest thing in the world, but actually what it means is people received Christmas trees at their doorstep in the middle of a pandemic. And then other functionality we've developed recently around shipping method overrides. Long story short is we can estimate when deliveries might not reach people on time for their birthday or their anniversary, whatever it is, and we're able to intelligently reroute them via other shipping methods. So let's say it was supposed to go Royal Mail, which is now taking too long. We can reroute it with like maybe DPD or something, and people receive stuff on time. So there's a lot of real benefits to real people from working in e-commerce, and I think especially when you work in a flower company, it's very much tied to human delighting. So that's something that we can find quite rewarding sometimes working here. Back to you, Chris.
Cool. Yeah, I just wanted to talk a bit about one of the projects we're currently working on. So we go to the next slide. It's basically warehouse management. So yeah, obviously, like operating a warehouse at scale on spreadsheets is not ideal. So we've been looking at third-party solutions for warehouse management. You know, obviously, like these are quite well-established systems. So this is something that, you know, we want to buy rather than build. Doesn't make sense for us to build something like this because it's not an area of our speciality. So so we're looking to integrate with a third-party solution, and yeah, apologies for the really boring looking diagrams. So we're going to build a service integration layer to help us communicate with the warehouse management system and potentially other systems that we need to talk to and integrate. So we basically, our infrastructure is hosted on AWS. So we're looking into some AWS options for communication. We use SNS SQS for our labeling service. And yeah, we're looking into Kinesis data streams as a potential option to get data out of our monolith app like into third-party systems. So obviously there's loads of benefits of you know, doing this integration. So we should get better visibility of inventory in the warehouse, better operational efficiency, time saved, better processes for goods in and out, and like it'll give us the ability to better track stock as it moves around warehouse locations. So we'll be able to see exactly where the flowers we need are or the packaging we need is in the warehouse at any given time.
Okay, so it goes without saying that we're hiring. We've got open vacancies right now for, I believe, mid and senior backend Ruby developers. But we've got plans throughout the rest of the year for testers, got potentially vacancies in MarTech, and anything else that might come up. I think there's also a front-end vacancy coming up later in the year. So if you're interested in what we've done and you'd like to know more, please head on to our careers page on our website and take a look at what we've got going on. Thank you very much, everyone. Happy to answer some questions.
Hey guys, that was a really cool presentation, and I think, you know, not many people, when they look at a business selling flowers online, think about this level of complexity connected with it. So it was definitely very cool from my perspective. One question that I wanted to ask you is connected with, so you're becoming this organization that scales, how you make sure, especially, you know, being far away from each other, that you discover these problems that, you know, Thomas or any other person in the business might have. So they actually move from, you know, something that exists as a problem to being observed to then being driven as something that Chris or someone else in the team would be working on.
Yeah, it's a good question. So, and especially in the remote world, it's harder to have some of those communication channels. So we've definitely had to work quite hard at those things. We have set up our organization structure in such a way that, as I said earlier, we've broken our tech teams into domain dedicated teams. At the top of each team is a product owner who works quite closely with a set of stakeholders. So, for example, we've recently gone through a company-wide exercise of setting our company OKRs. And on the back of that, the product owner has spoken to each stakeholder to whom they report and gotten an understanding of like how they want to fulfill those OKRs at their level. So for example, in our squad, we deal with fulfillment tech, we deal with accounting. So we've had to deal with those two, just as examples, those two entities. They've given us some ideas. We've then, our product owners then prioritize those against each other based on like the amount of impact it's going to make towards the business goals. And then that translates into where things come down to the tech team. In addition, I and the PO also have weekly or bi-weekly meetings with some of these stakeholders just to find out small things that are currently on their minds, and that's where we come up with stuff like this. So it's about, I think, having a framework where the whole company is pulling in one direction with OKRs and backing that up with a framework where like the product owner is constantly talking to stakeholders to understand like what their pain points are and what they need to do to meet those OKRs.
Great. And there's a question from Baden Ashford. Could you please talk briefly about how you manage code complexity in your Rails monolith with 50 developers and how Bloom and Wild approach and promote best practices in their code base?
Chris, do you want to take this?
Yes, I think, yeah, it's probably one for me. Yeah, I mean, like we're in a pretty good position here, like, fortunately. So we use a lot of design patterns in our code. So we use services, policy objects, decorators, stuff like that. So wrappers, things like that. And that's a practice that we've had, yeah, like since before I joined even. So the Rails monolith is about 6 or 7 years old now. So there is still some legacy code and stuff like that in there. But you know, we have managed to tackle tech debt over time by chipping away at it and like prioritizing it. So we have a 25% tech debt budget. One of the things we're actually doing now, which is quite interesting, is so we're looking, you know, over a period probably of years to, you know, split our code base up and transition to services. Not necessarily microservices, but perhaps like domain-based services. So, you know, like there could be like a shipping service that books deliveries with carriers, or a tracking service that tracks deliveries through the carrier network. So, and the way we're doing that is we're looking at the Shopify model. So, as of last Monday, we introduced Packwork into our code base, and we've shuffled a load of files around into sort of into domains. At this stage, it's just like sort of legacy components. So we split the code base up into legacy components, and the idea is over time we're going to flesh out the particular domains that we want to split the code in. And the great thing now is that each squad can own that piece of the code base, and you know, we're going to set up you know, some strict sort of boundaries between you know, components, so that they you know, we don't, you know, with public APIs, so we don't, you know, end up calling code that belongs to someone else directly. So we'll be able to make changes within our components without affecting any other team. And yeah, obviously we're going to have to set up a load of tooling around that. So especially with contract testing and things like that. But that's, yeah, it's quite an exciting project.
Great stuff, guys. Thanks a lot for your presentation. If you guys on the audience want to speak more about the challenges that Bloom and Wild is working on, feel free to reach out to Chris or Steve. And I'm going to ask you guys to press the red leave button and invite our last speaker. Thanks a lot.
Thank you very much.
Hey, Paul, how are you?
Hi there, I'm good, thank you.
Cool. If you can check whether your presentation is displaying correctly. Paul is part of the team at Snowplow Analytics and is going to talk about the architecture of their platform. So it looks like everything works well. So over to you, Paul.
Cool, thank you. I'm going to dive into another browser tab. So hopefully we have good luck today. He's on our side. Cool. So I'm going to dive into sort of a brief introduction of the Snowplow tech first, then how we are set up at Snowplow in terms of our engineering. And then I'll dive into one of our repositories and give you a quick run through how we structure things from an open source point of view, as you'll quickly see how we do quite a lot of open source work. So Snowplow at its heart really is all about building a behavioral data asset for a company. And we believe for a long time now that building this sort of asset is really important for a lot of organizations. And I think we see, as we go into the future, that we're going to want to give less and less away to the big organizations, your Facebooks and your Googles, and we're going to want to maintain control of that data asset ourselves as our own organizations. So what do we mean when we talk about behavioral data asset? Well, throughout all of your systems that you use, whether it be your mobile apps, your websites, your server and all the logic that runs there, maybe emails, your marketing things, all of those generate sort of your users doing things on your platform. All of these generate events, and then we build this data asset based on those core events. Those core events, they'll have properties attached, and there might be some common context as well that applies across all of these different events, and they lead to a whole host of use cases that you can support. And once you start building your own data asset. And so what does it look like from a Snowplow point of view? So it gets a little bit more complicated. So on the left-hand side here, we have a set of Snowplow, what we call trackers, and you can deploy these across a whole range of platforms, from your mobile web, server side, as I've already mentioned, pixel trackers for emails, and we can also integrate with third-party things via webhooks. And they all share a common protocol, which goes into this core Snowplow pipeline. The core part really of the pipelines is validation and enrich step. So all of the events you send from these trackers, they all they're schemed, so they all get validated as part of this initial step in the pipeline. This makes sure that all the data that eventually lands in your warehouse is of a really high quality, and it's exactly what you expected it to be. So if there's ever anything strange going on down here, maybe there's a bot on your website, and maybe there's a malformed request being sent, maybe there's some dodgy implementation in terms of one of your trackers, that'll never hit the data warehouse. And that instead gets logged to a thing we call failed events. So you can monitor and keep a track of what's going on. But you only ever get this good high quality data landing in your warehouse or your data lake or your real-time stream. We then also enrich this data. So we take various pieces of information and we add extra context into that event. So that might be working out like what browser and what operating system the event came from. It might be going off and calling a third-party API to go and add more information to it. It might be running some custom JavaScript to work something out in real time as the event gets processed. And all of that extra enrichment information gets loaded into the warehouse as well. All of this is really scalable and really resilient. And the whole point here is there's there's basically no data loss once an event hits the collector on the edge of this purple box in the center. And then once it's in the warehouse, that's where you can then deal with all of those different use cases that you might want depending on where your data is. So that core part, that's all open source. So this is the Snowplow open source part. This is where I spend most of my time as an engineer. And we're sort of very proudly open source. We invest a lot of our engineering effort into this open source engine to power data pipelines. And you can take that right now and you can spin one up, and that's where we'll dive in at the end of this talk. But on top of that, and underneath it, I suppose, I'll show you what I mean in a second by that, we also have something called Snowplow Insights. And this is our management platform. This makes using Snowplow a little bit easier. Not only do we set it up and manage it for you, but we also add like a layer on top of that, which helps you manage those schemas, how your pipeline's configured, and when your data modeling jobs execute, all those sorts of things. It removes some of the challenges around doing that. So as we break it down a little bit more, and that core open source bit, this is basically that part. So you've got the collection, validation, and enrich that I've already described in the failed events. We also then write it to a real-time stream. So we're very cloud focused. So we are predominantly using Kinesis in AWS and PubSub in GCP as the two different real-time streams, depending on which cloud platform you deploy Snowplow into. You can then write additional consumers on this real-time stream. So if you've got real-time use cases, you can do them there. We then write that stream directly into a data lake, so S3 or GCP, GCS, Google Cloud Storage. And then we take, as depending on the platform, this diagram's partly true. If it's on AWS, then we'll take the data lake and we'll load that then into the warehouse. If you're on GCP, we basically go straight from the real-time stream into BigQuery, and we use something called streaming inserts to write to BigQuery. And then we have a whole host of open source data models that allow you to model that raw data. We call that the atomic data. We imagine that as like an immutable data store, something that never really changes. And we then have these models which turn it into very common aggregations that people want to use. So for instance, on the web, you might have something like page view aggregations, session aggregations, and user level aggregations. So things like how many times has this user visited this website? It'd be a user level aggregation. Page view aggregation might be how long was the user on this page? How far did they scroll down the page? Things like that, that our trackers right back at the beginning will be tracking. And then then when we come to the non-open source bit, this is where the platform management sort of comes in. So we fully manage the Snowplow stack. What's different about this isn't typical software as a service. We don't own this infrastructure. We deploy it into your own cloud account. So you typically create a sub account inside of your cloud, and you give Snowplow, the Snowplow analytics team, access to that. And we deploy and manage Snowplow inside of your cloud account. This means it's a completely first party setup. You put your own domain name on it, you completely own the whole thing. You can turn it down, turn it off whenever you want. You own that asset. We don't have any access to that. We just manage it, and it's all automated. So all of this is done with Terraform, ultimately, Kubernetes on GCP, and soon AWS. And yeah, so we're basically taking control of that in terms of all the help and setup there, all the complex scheduling that needs to happen to load into the warehouse. And then there's also support teams to help you more deeply understand how to get the most value out of your Snowplow pipeline. So we split Snowplow into these three layers now. We call them BDM, BDE, and BDF. And we call Snowplow collectively a BDP. Apparently, we really like acronyms now. So the open source bit is this BDE bit in the middle, this core part of Snowplow. This is where the diagram I've showed you that you can just sort of see there, where we go through that collection, validation, enrichment, and then loading it into the warehouse. That's the engine, as well as all the trackers. They're all open source. This deployment, this data fabric, this is the deployment. So all of that automation around the deployment, all the Terraform, all of the monitoring, scaling, all of that stuff that that's part of that BDF. That's a core part of what we build as an engineering team to ensure that deploying Snowplow, when you're using Snowplow Insights, is as seamless as possible. And we also think of things like SLAs and such around uptime and things like that. And then we have a UI which sits on top of the engine, which helps you with configuring it. Typically, you can do everything that the UI and the API offers you on an open source from an open source pipeline. But being able to click on a website and upload your schemas and get some validation in there to make sure that they're right and they make sense. Monitor your jobs that are running, all those data modeling jobs, and restart them if they failed. Do an ad hoc run if you want to, without having to figure out how the API works of the server or the orchestration tool that you use. That makes it a little bit easier to have that extra layer. So this behavioral data engine is open source, and this is the repo I'll start in a second. We'll dive into here. This is where we solve those core challenges and all those compliance challenges as well. And we see it's broken down here into 5 distinct parts, which is what how we typically think of a Snowplow pipeline. So the trackers, collectors, enrichment, and validation happens as part of the enrichment, the storage tier, and then the data modeling tier. And by going to Snowplow on GitHub, you basically get access to the whole world of Snowplow that you need to be able to set up a Snowplow pipeline. And it's a good jump off spot. So there's not really any code in Snowplow. There used to be, and there's not anymore. It's basically a jump off point now into the rest of our open source repositories, of which there are many, many open source repositories. The behavioral data fabric that I've mentioned, this is the tech for managing the infrastructure that sits underneath that. So this is what we're referring to as private SaaS. So every single client that we have has a dedicated set of infrastructure. So we're managing hundreds of Snowplow pipelines. And to do that, we need to make sure it's all automated and it's all very easy for us to monitor and maintain that. Of those hundreds of Snowplow pipelines, we have a technical operations team of 5 people, globally distributed, and we have a support team of, I think, 6 or 7 people, right, to manage those hundreds of pipelines. So it's important that these things work really well, and that they give us that kind of assurance and that level of monitoring and automation to be able to achieve what we do. And then there's a behavioral data management, which helps you, and this is the UI, you can see. This helps the people that are using Snowplow every day to get more out of that experience once they've got their Snowplow pipeline up and running. So how do we do all of this with an engineering team? Well, there's 21 of us in our engineering team at Snowplow, and we're split across these 3 different layers. So we've actually broken our teams down so that we very much focus on different parts of this layer. So the behavioral data management has 2 teams, and data workflow is the main one, I think, that they build that UI that I've just shown you. And then we have a team called product-led growth. There's a new experience now called Try Snowplow. It makes Snowplow really easy to set up and just run like a trial experience for 30 days. And they build out this trial experience, which has got some management and some recipes to help you get going and understand Snowplow a little bit more. There's the data capability team, which is part of the engine. They build the core pipeline. So from the collector to the loading to the warehouse, that's what the data capability team work on. And the data value team, they work on the edges of the Snowplow pipeline, so the trackers and the data models. And we also have a couple of relays that relay that data into other platforms, like into Kafka and things like that. And then there's our technical operations team, which build out that data fabric. And they built it in such a way that when the behavioral data engine teams build different parts and different components or upgrades, that we can edit that Terraform. We're empowered to go from the code all the way to rollout, and ensuring that we're building all those parts that are needed to get that Snowplow pipeline into production. So to break it down, management tools in data workflow, the Try Snowplow experience in the product-led growth team, data capability, the core pipeline, data value trackers and data models, and the technical operations team are worried about the deployment and the scalability of the pipeline. So our teams are very flat. Each team has between 4 and 6 engineers, except for the product-led growth team, which is a little bit smaller at the moment. And then one of those engineers has this extra responsibility as a delivery lead. I guess you could really call them a team lead, maybe in a more traditional setup. And their role is not to like give people work, but more to make sure that everything's humming and is working as the way we expect it to be working. So it's just an extra responsibility rather than an explicit like leveling within the team. And we also have a number of coaches. Often the delivery leads are the coaches. And the idea in here is every engineer has a coach associated to them. And that just gives you somebody else, someone outside of your engineering team. So your coach will always be from another engineering team, just to bat ideas around with, to talk to, just another peer that you're sort of, you've got this like relationship with to help you throughout your career, whatever question it might be, but from a more coaching / mentoring sort of side of things. And really, we really try and make it as a productive and empowered environment as we can from an engineering point of view. Like I said, there's no real leadership within the teams. It's very flat. So you make your own choices, you make your own decisions, but you've got this sort of network, delivery leads and coaches to use to help you make the right decisions. And to, when you're making like maybe a choice that impacts how the open source pipeline is set up, you might want to bounce some ideas around to get some different opinions, because that can have quite a big impact. So you've got that network around you within Snowplow. So let's dive into Snowplow really quickly. And let's see if this works. Hopefully you can all see this. So this is where the magic happens, I guess. And this is the homepage of Snowplow. So here, there's the link off to the different parts of our estate. And you can also see quite a lot of information here to get going. So we have a version compatibility matrix. This helps you understand which parts of the Snowplow pipeline work together from an API compatibility point of view. It's typically pretty compatible all the way through, but I think quite interesting to just get some clarity on that. We have a public roadmap, so you can see what's coming up and what we're working on right now at Snowplow. That covers our Insights product and our open source product. We have links off to our Try Snowplow and commercial offering, and then we have that diagram that I've just shown you today. And then you can see it all broken down. So from a tracker point of view, a whole host of platforms. Collector and enricher, sort of generally you'd run them on like an EC2 instance or something like that, and you'd have them scaling. And then you've got your various loaders into the different warehouses. We have some testing tools, Mini and Micro. Micro is a Docker image, and Mini is like a more fully fledged pipeline in a box. And then we have some what we call analytics SDKs, which help you work with the real-time stream if you want to work with those. We also run an open source discourse, and as an engineer, it's a place where I live. So I hang out on our discourse and I help other engineers who are trying to spin up a Snowplow pipeline. I help them set it up, help them with their tracking questions, help them with their modeling questions. And there's a whole host of interesting information there as well. And then we have a couple of Twitter places you can keep an eye out as well. So I'm out of time. I'm getting on a bit. So the thing I mainly maintain these days is the JavaScript tracker, which is one of our most popular trackers. And we've recently just rebuilt this so that it now isn't just a traditional web-based tracker that loads maybe through a snippet in GTM, but can also now be directly embedded in your application as an NPM package. So we've taken a newer, like a slightly different approach, perhaps. A lot of analytics tools, you load them via like Google Tag Manager or something, and that still works. We've still got this tag-based solution. But we now also, when people are building modern React apps, Angular apps, things like that, you want to directly embed that first-class tracking into your platform. So now we're helping people do that and going another step with our new tracker that's based on NPM as well. This is also a mono repository, so there's a brand new plugin architecture where you can build your own plugins. It's been really fun sort of being able to rethink and rebuild this and sort of pick all the latest tools, but still maintain, quite interestingly, some crazy browser support. So we still support IE9, and we do that because our tracker needs to be we need to work on the lowest common denominator to make, you need to know if you're running the Snowplow tracker on your website, are people visiting my website on Internet Explorer still? And if they are, maybe we still need to support it as an organization. So that's where we need to make sure that we're supporting a really wide range. So we have a lot of automated tests to make sure it all works. We use our own technology to do this. So we use Snowplow Micro to validate the tracking in our automated tests. So we have like a little test rig that spins up every time we do a commit, and it fires a whole host of events into a Snowplow Micro and then validates that the events arrive into Snowplow Micro and validate as we would expect. So please feel free to go to Snowplow, have a little look around. The main pipeline is built in Scala, and then obviously the trackers are built in a whole host of languages, and data modeling is predominantly SQL across all those different warehouses in a variety of different dialects. So that's about it from me today. We've obviously got plenty of jobs. We're growing very quickly. So yeah, I look forward to hearing from everybody.
Yeah, thanks a lot, Paul. Really cool presentation. You also got a shout out from Bloom and Wild team, who's actually using your product. So that's great. Like, what do you think is like the key challenge for you in that sort of next 12, 18 months? Like, what's exciting? Like, we're always trying to, when part of the beauty of being in a tech company is that you get to work continuously on new things. So what are the exciting things that you're working on?
Yeah, so one of the big things that we've got to focus on is making open source easier than ever to get going with. Mm-hmm. So I'm pretty excited about this because I think it's going to really help adoption. So you've probably already gained from that presentation, Snowplow is relatively complicated. There's a lot of moving pieces, there's a lot of components. So making that as easy as possible to get up and going in terms of like a brand new user and you getting started. So we're looking at more automation around that sort of like those early adopter or those early open source users and making their life as easy as possible. So I'm pretty excited about that. And I think the other big thing at the moment in our industry is all the change around privacy. So there's, we've just seen what Apple have been doing with iOS 14.5. That's having a huge impact on the advertising industry. And we're seeing like all the browsers constantly adapting and changing their approaches to cookies and things like that. So yeah, keeping up with that and seeing what's going on, that definitely keeps me on my toes as part of the data value team, and thinking about how you can still extract value. But one of our core mantras is to make sure we're doing all of these things with privacy in mind, right? We're advocating for better privacy at Snowplow. We want people to, we want you to understand and trust in this data collection as a user.
Cool, great. Thanks a lot, Paul. That was really cool talk. And thank you everyone for joining today. Again, feel free to reach out to Paul, check the jobs, check what the guys are doing. And we wanted to thank you for spending the best time of your lunch break with us. And we're looking forward to seeing you on another event soon.